Welcome back to Fun with Physics. My name is Kyle Danes with your visual artist, Nathan Pierce. Our second lesson is going to be on Newton's third law. Once again, we will delve into the incredible mind of Sir Isaac Newton. Newton's third law states that for every action force, there's a simultaneous reaction force equal in magnitude but opposite in direction. In other words, when you push on an object, the object pushes back on you with the same force. Him is pushing on the wall with an applied force, and for him not to fall through the wall must push back on him with an equal and opposite force. In the free body diagram for him, we can see that the ground pushes him forward with a certain force, which gives him the force needed to push on the wall. This force, however, is balanced by the equal and opposite reaction force of the wall pushing on him. Due to this, and the gravity being balanced by the normal force, him's net force is 0. An application of Newton's third law is the example of a rocket ship. To demonstrate this example, him will once again make an appearance. When him starts up the rocket ship will burn fuel, pushing the gas produced towards the Earth. As the rocket pushes on the expanding air, the air pushes back on the rocket, causing it to move upwards. In the free body diagram for the rocket ship pushes exhaust out the bottom, and as it pushes exhaust out the bottom, the exhaust applies a force upwards on the ship. The force of gravity also acts on the ship, but the force of exhaust on the ship is larger, moving the rocket ship upwards. Making his last debut, him is going to row his boat along the river using 2 oars. As he pulls on the oars push on the water. The water then pushes back on the oars, applying a force forward on the boat, causing it to go forward. For the free body diagram of him, the boat, and the oars, there is a force of gravity balanced by the normal force or force of buoyancy on the boat. There is also a force forward on the oars, which propels the boat forward. Because the force of the water on the oars is greater than the water resistance, the boat moves forward. In this scenario, we are assuming a weightless environment as Nathan is able to fly. As Nathan approaches and then pushes the vehicle, Nathan exerts a force forward on the car, however, the car also exerts a force backwards on Nathan. Due to these forces, while both Nathan and the car are exerting a force on each other, the car accelerates forward and Nathan accelerates backwards. This can be further explained by a free body diagram of both the car and Nathan. Since we are assuming a weightless environment, both Nathan and the car have neither a gravitational or normal force. However, when Nathan exerts a force forward on the car exerts a force equal in magnitude backwards on Nathan. Thus, Nathan experiences a net force of some number backwards and accelerates backwards. The car experiences a net force of some number forwards and thus accelerates forward. In conclusion, Newton's third law of motion states that for every action force, there is an equal in magnitude but opposite in direction reaction force. This law can be used to explain numerous scenarios in everyday life. These include how rocket ships fly, how a boat moves through water, and can also explain how a car moves or an animal walks. This has been Fun with Physics. Until next time, I'm your host, Kyle Danes, alongside your visual artist, Nathan Pierce. We'd like you to have a wonderfully enlightened day.